Good morning, mathematicians. Welcome to part 2 of the Galois Cohomology saga. The newest replacement for office hours. I hope you're ready to learn some Galois Cohomology today. Part 2. Because that's what we're doing from now on. Until we finish this random PDF. What does finish mean? I don't know. I don't really know. Good morning, Ken. First in chat. Good morning. Okay, I gotta pour myself some coffee here. So, I guess the first thing to start off with is that hello, Sergio Polar Bear. So we left off with this result that the group cohomology is the unique delta functor such that all of this is true. And was there even given a proper definition? Let me see. Defined as the derived functor. You can check out the beginning of Hartshorne's chapter 3 for more info. I did check out Hartshorne's chapter 3 for more info. Yeah, I think the point is, I was going to say, basically there's a theorem of Grothendieck that characterizes, uniqueness of delta functors from how they behave on injective resolutions. So, hello, Fimno. Yeah. So I think we're just gonna leave it there, as and just say, okay, there's a theorem that does it, because it's not so much the point, right? Yeah. Although they say definition, but they just say, oh, there are functors that have this behavior. So, and we'll talk about it in the next section. Okay. The saga continues indeed, Sabi. Right. So these are all given by our good friend Ext. In fact, I think this should be ZG, no? Oh, Hom G. Yeah, hang on a second. This is maybe why I should be reading from an actual textbook. Surely. Oh no, because it's the fixed points are the trivial. The fixed point should be given by but then why is it Z? Hom G Z A. Right, Z with the trivial action. Is it just me or am I big? Oh, right. Let me. I did grow a lot last night. I had a lot of food. Okay, hopefully that's good. I think that'll probably be a good position. He's big and very quiet. I mean, I'm trying not to shout like usual because my roommate's asleep. The neighbors upstairs, you guys probably can't hear, but the neighbors upstairs are like definitely stomping around their apartment with shoes on, which is insane behavior. And all of you are exhibiting insane behavior if you do the same thing. Right. So yeah, this should be Z with the trivial action. It should be Z with the trivial action, I think. And okay, we're gonna deduce that this is always XZA as G modules. Stompers are the worst, yeah. At least they don't wake me up in the middle of the night. Hello, Paul Maurice. So we play the usual game, projective resolution of Z. Good morning, Edit Smith. We apply our contravariant functor, and we take cohomology. Classic group cohomology stuff. And then we've got our usual, I don't know what to call it. I'm, the word canonical drives my gears. But our most favorite projective resolution. Let's say it that way. Okay, a module is relatively injective if it is a direct factor of a coinduced module. Which is to say, if we can sum it to get an induced module. Interesting. You're probably right, Paul Maurice. We probably should be looking at Serre's local fields. Yeah. And in fact, actually, a friend of mine suggested another really nice book. But it was like 300 pages. And I didn't quite feel like doing it. Should we switch to Serre now? Let's see. I'll have to maybe get a copy. Let's see. Let's take a look at Serre. Yeah, I'll find myself a more proper PDF. Let's see, DVRs, completions. What else we got going on? Oh, they're gonna make me. Oh, group cohomology. Okay. Oh, and then it doesn't let me see the preview of the rest. Okay, well maybe, yeah, I don't know. We might consult Serre at some point, but let's continue through this random PDF. Oh, okay, good to know. Good to know. I think they set some conventions. Induced was tensor product, I think. Let's see. Yeah. Induced was that you tensor up. And co-induced was a HOM. Induction for co-induction. Okay. And compactly supported induction for co-induction. Okay. Good to know. I'm sure I'll forget that and get confused about it, but thankfully you guys will be here in chat to set me straight. Okay, so if A is relatively injective, then this is true. Makes sense, on the surface level. Let's look at the proof. It suffices to consider co-induced modules because then we can just break things up that way. Wait, that doesn't make sense? What doesn't make sense? The proposition? Oh, what you said. Yeah. I didn't think too closely about it, but there is, yeah. Yeah, it definitely gets confusing. I've said this before with all of these inductions, and then like ordinary induction versus parabolic. So the adjointness side of induction of representations for finite groups is like on the opposite side of induction and Jacquet, but actually Bernstein's second adjointness theorem tells you that you have adjointness on both sides because you have induction and Jacquet to opposite parabolics. And then that's to say nothing of compact induction. So you should try to prove these before looking at the proof. You're right. But I don't know. I started looking at this one. Maybe the next one. We'll see. Yeah, but that normalization matters. I mean, now I'm completely normalized parabolic induction pilled. Actually, you can do normalized parabolic induction without twisting by the modular character. Sarah does have a book on Galois cohomology. This is true, and we may turn to it soon enough. Okay, let's see. If A is co-induced, then it's equal to this Hom, and then Hom Bx is Hom Ba is isomorphic to Hom Ba. By taking such a Hom to the map that takes such a B and sends it to this composition. I feel like I should write it down. Hom B, what was it? Hom Bx to Hom Ba? And X was Hom. Oh, but yeah, that makes sense. Sorry. A is Hom lambda X. Right, so I take a B in here, take, F in here, B in here, and then, I don't know, let me call this, phi. So then phi of F at B applied to some S in my ring should return the element, let's think here. Right, I can go F applied to B, which lands me in X, and then I can act on it by S. How do they define relative injectivity? It was this. It was if the higher cohomologies vanish. So, why are these harms the same? From the above, wait, what the hell are the PIs? We chose a projective resolution somewhere? We're in the proof of the proposition now. The definition is right above it. Yeah, maybe we should just go to SARE. Because I guess P is supposed to be a projective resolution of P is supposed to be a projective resolution of A. Or sorry, of B. P is supposed to be a projective resolution of B. No, of Z, sorry. Of Z. Right. Okay, so we have a resolution into Z, and we have this comparison of harms. So I mean, we can take harm px, and I mean we have harm p0 x isomorphic then to harm, or sorry, let's see. Okay, we've got harm. Yeah, the first one should just be z x. A is that, B is that. From the above, it follows that all of the harms are isomorphic. Now, why would that be the case? This is one of the office hours of all time. Indeed. Yeah, I don't know. Maybe this was a bad idea because it's just me staring at a screen, having a think. Yeah. Hey, you guys wanted this. You were excited for this. Or maybe that's just what I told myself. For the co-induced case, it can be shown. Thanks. Okay. Maybe we should move on and come back to this when we have a different book that we're working out of. No, I should be able to try this. I don't understand why this would follow, though. Yeah, I have no idea. It looks like they're driving two functors or something along those lines. Yeah. And these are all naturally isomorphic by adjunction. I see. Yeah, but I don't like the fact... Oh, that's not what we're studying today. Oh, God. My life's a mess. Right. Maybe we're using some adjunction nonsense. Oh, maybe... I see. Okay, hang on. So we've got... Wait a second. So we have hom bx, hom b, hom lambda x, right. So wait a second, which way does our adjunction go here? So what, I can replace it with induced, with inducing b over here or something? Or forgetting b to an abelian group? Which way does our induced co-induced adjunction go? Maybe I should look it up. The mysterious isomorphism. Oh. I didn't realize it was so mysterious. Nah, I don't. Whatever's going on here. Of representations. No, this is probably going to be the wrong way around or something. Ugh. Surely they must mention it here, right? Okay, I'm gonna try and get Sarah for tomorrow. I think maybe we'll look at Sarah or this other one that my friend mentioned. Right. We must just be forgetting. Sorry, we must just be forgetting down to abelian groups, right? That must be the. If it's a junction on this side, the birds are calling indeed. What am I doing? That should be a B. No. Okay, we're just gonna move on. We're gonna come back to a proper book. Because I don't get what they're trying to do here. B is, wait, what's the assumption on B? Relatively injective. Relatively injective. Wait, the assumption is that A is relatively injective. It suffices to consider co-induced G modules, since then we can induce the general case. Right. Yeah, so we're just considering A co-induced. I don't know. Okay, dimension shifting. Time for New Age spirituality theorems. We'll talk about this, and then probably that'll be it for today. Okay, suppose, what is this? What is this choice of notation? Star and prime? I guess there's worse things you could do, but just write like ABC. Ugh. Terrible. Okay, if the sequence is exact, and the middle term is co-induced, then we get isomorphisms of these cohomologies. That's nice. That's a nice little theorem. I guess we'll get a long exact sequence, and then the co-induced thing, the previous vanishing theorem, is what does it. Yeah, I mean, yeah, it should be pretty straightforward. Yeah, that's exactly what the proof is. Okay. Remark 17. This functor is completely HQ plus 1 is completely determined by HIG for I less than Q, giving the claimed uniqueness. Huh? What? Is this going back to the claim about the uniqueness of this as a delta functor? This shows that the functor is completely determined. Oh, the remark is saying that this shows it. Why? This is wild to me. Chat, am I cooked? You gotta let me know if I'm just cooked right now or what. Okay, time for explicit formulas, baby. I wonder what SAGA can do for group cohomology. Can you do group cohomology in SAGE? Can you specify a module action? Maybe not. It seems really explicit. It seems like there should be a way, but it's also kind of nasty with equivalence classes, so I don't know. Galois would be disappointed in me? Maybe. I can always take a star to be the co-induction of the underlying group. Okay, let's look at this. So, the CIA is finally here for me. That's the helicopter you hear overhead. If you can hear it. I'm always confused what you guys can hear and what you can't, because there's some things that I think you can hear and then you can't, but then Boris is hearing the birds. Okay, so what was it? A star, A prime. You can always take star to be the co-induction of the underlying group of A prime. And then A is its kernel. Interesting. Right. Nice. That's slick, Arad. So I guess we could even write it as hom lambda a prime naught and actually, what is this nonsense? I'm gonna go. Let me do it this way. Let me build the sequence this way. This will be A. A naught will be its underlying abelian group. I guess we could call this thing A star, and maybe K for a kernel. Ka, because I just heard a bird. Ka. Right. Right. And then this is basically just the unit of this adjunction, right? But let me, right. Yeah. The unit is just the action map. Wait. No, let me think. I'm a smooth brain and I gotta try and get wrinkly. What are we gonna do? We're gonna take a hom in here and send that hom to, yeah, what is it, just hom at the identity? Is that the whatever unit, co-unit of the adjunction, whatever it's supposed to be? I guess co-unit. I guess co-unit, because we're going out of the composition. That makes sense, right? Okay. But then as for the claim that the functor is completely determined, right, okay, I see. Right. Huh. Interesting. I didn't know that. You misled me? You bastard. Is this not a hom? I mean, the one thing I was thinking of is it surjective? I mean, it seems like it should be, right? You should be able to take a hom, choose an arbitrary element of A, demand that F1 is A, and then, I mean, that should determine the rest of the map, right? Because then you ask, well, what is an F at some G? Well, that has to be G dot F1, right? So that should determine a map just fine. So it's definitely surjective. But this is ROL to the identity. Well, do we know which way is we should replace it over here and define this to be the co-kernel or something. Well, it's 9:30, so I think we'll leave it there. At least the dimension shifting theorem is should be understandable. I believe it. Will we keep going through these notes? We might. we might actually use these notes still. But okay, I'm gonna grab a PDF copy of SARE, and we'll maybe consider using SARE, and or this other book my friend sent me. So until then, go prove some things about Galois Cohomology.